Hello, Diamond. Sure, fine. Okay, right now. What's wrong with you? లేదు.
Every resource
find outside of the constructor. Red Mustang, you stop the red Mustang. Card 2. Function. We need to set up the parameters. Self is already provided to us. Self means this object we're creating right now, this car. So what are some attributes that a car should have? A model, that could be a string, like a BMW. A year, that could be a number. A color. Let's add a boolean of for sale. Is the car for sale or not? That's true or false. To assign these attributes, we're going to access self. Self dot the name of the attribute. Self dot model equals the model we receive. These are parameters. When we receive the name of a model, we will assign it to this object. Let's do this with year. Self dot year equals year. Self dot color equals color. Self dot for sale equals a model, year, color, and if it's for sale or not, represented by a boolean. Now, to construct a car object, we need a unique name for this car. Let's just say car1. Car1 equals, take the name of the class, add a set of parentheses to invoke the constructor. We're going to do this almost exactly like a function. We have parameters set up. We need to send a matching number of arguments. Self is provided to us behind the scenes automatically. We need a model, year, color, and if it's for sale or not. So pick a car of your choosing. I'll pick my favorite car. The model will be a Mustang. For the year, I'll go with the recent year of 2024. A color, I'll pick red. Is the car for sale? I like this car, so no. I will set that to be false. Make sure false is capitalized. Let's see what happens if I attempt to print our car object of car1. What we're given is the memory address of this car object, where it's located. But I would like one of the attributes located at this memory address. Instead of printing the object itself, we're going to access one of the attributes found within this car. We will follow the name of the car with a dot. This dot, it's known as the attribute access operator. I would like the model of car1. That would give me Mustang. Let's access the year. Take the name of the car, car1, dot, the year, 2024, followed by the color, car1, dot color, red, car1, is it for sale? We'll print that. That is false. Now let's create a second car. We're going to reuse this class to create a second next car. We will create car2 equals car. We'll pass in some different arguments. A Corvette. The year will be different arguments. A Corvette. The year will be different 2025. The color will be blue. Is this car for sale? Let's say that is true. Instead of accessing car 1's attributes, let's access car 2's attributes. That would give us a Corvette, the year is 2025, the color is blue, for sale is set to true. Or even a third car. Car 3 equals a new car. We will pass in a string of charger. The year, 2026. The color will be yellow. Is this car for sale? Let's say that is true as well. Then I will print car 3's attributes. The model is charger. The year is 2026. The color is yellow. For sale is set to true. With classes, they can take up a lot of space. For better organization, you can place them within a new Python file. So let's cut our class, and we will create a new Python file within our project folder. File, new, Python file. The name of this Python file is going to be all lowercase, car. Then we will paste the class that we cut originally. Class car, which has a capital C. So from our main Python file, we're going to import our car file, our car module. From the name of the module, car, import the name of the class, car. Then when I run this program, nothing should change. We should still have access to all of our car objects. You could either keep your classes within your main Python file, or import them if you would like to organize things. Let's talk about methods. Methods are actions that our objects can perform. Within our class, we will define a method of drive. Self is going to be provided to us. When we invoke the drive function, let's print you drive the car. What other things can cars do? Let's stop. We will print you stop the car. Let's take car1, access the drive method. You drive the car. Car2 also has a drive method. You drive the car. Same thing with car3. You drive the car. Let's access the stop method. Car1.stop. Car2.stop. And car3.stop. These methods are identical for each car object. Instead of printing the word car, let's insert the model of the car. I will convert these print statements to F strings. Instead of the word car, let's add a placeholder. Let's add self.model. Self is referring to the object we're currently working with. Use the attribute access operator, followed by the name of the attribute. Let's also do this with the stop method. Self.model. Let's take car1, use the drive method. You drive the Mustang. Car1.stop. You drive the Mustang, you stop the Mustang. Let's do this with car2. You drive the Corvette, you stop the Corvette. Car3. You drive the Charger, you stop the Charger. Now within our F strings, let's insert the color. I'll add a placeholder, self.color. Do this with stop as well. Self.color. You drive the yellow Charger, you stop the yellow Charger. Car1. You drive the red Mustang, you stop the red Mustang. Car2. You drive the blue Corvette, you stop the blue Corvette. Let's add one last method. Let's create a method to describe our car. We'll print the details of the car. Let's print, I'll use an F string, add 3 placeholders. Let's print self.year, followed by self.color, then self.model. We'll take car1, use the describe method that we created. Describe car1. Car1 is a 2024 red Mustang. Describe car2. Car2 is a 2025 blue Corvette. Car3 is a 2026 yellow Charger. Alright everybody, so those are objects in Python. An object is a bundle of related attributes. Attributes are variables that an object has. And methods. Methods are functions that belong to an object. They define what this object can do. And well everybody, use the car1 is a 2024 red Mustang. Describe car2. Car2 is a 2025 blue Corvette. Car3 is a 2026 yellow Charger. Alright everybody, so those are objects in Python. An object is a bundle of related attributes. Attributes are variables that an object has. And methods. Methods are functions that belong to an object. They define what this object can do. And well everybody, that is a summary of object-oriented programming using Python. Hey everybody, today I gotta talk about class variables in Python. Class variables are shared among all instances in Python. An object is a bundle of related attributes. Attributes are variables that an object has. And methods. Methods are functions that belong to an object. They define what this object can do. And well everybody, that is a summary of object-oriented programming using Python. Hey everybody, today I gotta talk about class variables in Python. Class variables are shared among all instances, meaning objects, created from a class. Instance variables are defined inside of the constructor. Class variables are defined outside of the constructor. With class variables, they allow you to share data among all objects created from the class. With instance variables, each object has their own version. With a class variable, all those objects share one variable. Here's an example. We will create a class of student. We also need a constructor. When we create a student object, this constructor is automatically going to be called, but we need to pass in some arguments. We are provided with self. Self refers to the object we're currently working with. We will set up a name parameter and an age parameter. We will assign self, the object we're currently working with, set the name attribute to equal the data for the name that we receive from this parameter, and self.age equals age. Let's construct 2 student objects. We will have student1 equals, then call the constructor for student. So type the name of the class, followed by a set of parentheses to invoke it. This will automatically call the constructor, but we have to pass in data for the name and the age. For the name, let's pass in SpongeBob, because basically everybody in the world knows who SpongeBob is. I don't know how old SpongeBob is, we'll say he's 30. We'll create another student object, which we will refer to as student2. We will call the constructor of our student class, pass in data for the name and age. Student2 will be Patrick. Patrick will be 35. Okay, let's make sure this works. Let's print student1's name followed by student1's age. And we should get SpongeBob, and his age is 30. Let's print student2's name and student2's age. Patrick is 35. Now we'll create a class variable. Class variables are defined outside the constructor, and they are shared among all objects created from that class. Each object has their own name and age property. These are instance variables. But class variables are defined outside the constructor. Each object will share this one variable. So if we're working with students, let's say there is a class variable of class year. What is the graduating year of this class? 2024. Now, let's print student 1's graduating year. Print student 1 dot class year. Okay, so SpongeBob has a class year of 2024. That's when he's graduating. Let's check student 2. Patrick, his age is 35. His graduating class year is 2024. Now, with class variables, you can access them through any one object, such as student 1 or student 2. It's good practice to access a class variable by the name of the class, rather than any object created from the class. Since we're accessing class year, we'll access this class variable by the name of the class of student. Make sure the S is capital. This helps with clarity and readability. If I was looking at this print statement, I can tell that class year is a class variable because we're accessing it directly from the class, and not any object created from the class. Since we're accessing class year, we'll access this class variable by the name of the class of student. Make sure the S is capital. This helps with clarity and readability. If I was looking at this print statement, I can tell that class year is a class variable because we're accessing it directly from the class, and not any instance from this class. Without looking at this class, I can't tell if class year is an instance variable or a class variable, but if I access it via the class name, it's more explicit. So it's good practice to access a class variable by the class name itself, and not any one instance of this class. Let's create another class variable. We'll create a class variable to keep track of how many students we have created. This class variable will be num students, meaning number of students, equals 0. So within our constructor, we can write any code that we want. This code will always be executed when we instantiate an object. I would like to take our number of students and increment it by 1 each time we construct a new student object. So instead of using self refers to the object we're currently working with. If we're constructing student 1, just imagine we're replacing self with student 1, or student 2 if we were constructing student 2. If we're going to be modifying a class variable, in place of self, we'll use the name of the class, student. Access our class of student, get the class variable of number of students, then I will increment it by 1, plus equals 1. We are constructing two student objects. I will print access our class of student, get the number of students, and print it. We're constructing two student objects. If I print the number of students that we have, it should be 2. Then, just to be sure that this is working, let's construct a third student object. Student 3, equals student. This student will have a name of Squidward. Squidward's age will be 55. Now we have 3 students. And for good measure, let's construct one more. Student 4 equals, we will create a new student with a name of Sandy. Sandy's age will be 27. The number of students is now 4. Just as an exercise, using an f-string, let's print the student class's class year as well as the number of students. I will print, use an f-string, my graduating class of, let's add a placeholder, access the class of student, then access the class year. My graduating class of 2024 has, then we need the number of students. We'll add a placeholder, access the class of student, access the number of students, has blank students. Let's see if this works. My graduating class of 2024 has 4 students. Now, if I were to change 2024 to 2025, my graduating class of 2025 has 4 students. Let's print the name of each student. These are instance variables. Student1.name. Then we need student 2, 3, and 4. My graduating class of 2025 has 4 students. SpongeBob, Patrick, Squidward, Sandy. All right, everybody, so those are class variables. Class variables are shared among all instances.
sitting down in the restaurant, waiting for the check. We had made love earlier that day with no strings attached. But I could tell that something had changed, how you looked at me then. Krista, come right back. I've been waiting for you to slip back in bed when you lit the candle. And on the Lower East Side, you're dancing with me now. And I'm taking pictures of you with flowers on the wall. Think I like you best when you're dressed in black from head to toe. Think I like you best when you're just with me and no one else. Krista, come right back. I've been waiting for you to slip back in bed when you lit the candle. And I'm kissing you, lying in my room, holding you until you fall asleep. And it's just as good as I knew it would be.
Is of a class.
Stay
SpongeBob,
with
Patrick,
me.
Squidward, Sandy.
I don't want you to leave. Krista, come right back. I've been waiting for
Alright everybody, so those are class variables. Class variables are shared among all instances of a class. They are defined outside of the constructor. The benefit is that they allow you to share data among all objects created from that class. And well everybody, those are class variables in Python. What is going on everybody? So today I gotta talk about inheritance in Python. Inheritance allows a class to inherit the attributes and methods from another class. Much like how a child in real life can inherit traits from a parent. Inheritance is going on everybody, so today I gotta talk about inheritance in Python. Inheritance allows a class to inherit the attributes and methods from another class. Much like how a child in real life can inherit traits from a parent. By having a class inherit attributes and methods from another class, this helps with code reusability and extensibility. In this example, we're going to create an animal class. The dog, cat, and mouse class will inherit attributes and methods from the animal class. We will create a class of animal. Then I will define the constructor. When we construct an animal object, let's pass in a name. It's not required, but it might be good for this example. We will assign the attribute of name equal to the name we receive. Let's also add an attribute of is alive. Whenever we create an animal, we will set their is alive attribute to be true, and that is a capital T. All animals can eat. Define eat. We will print using an f-string, add a placeholder, self.name, the name of this animal, is eating. All animals should be able to sleep. Define sleep. Print, I'll use an f-string, insert self.name is sleeping. And that is all we need for the animal class. Let's define class dog. For a child class to inherit the attributes and methods from another class, after the class name that's going to inherit, we need to add an inheritance list with a set of parentheses, then list the name of the class we're inheriting from, the parent. The dog class is going to inherit all of the attributes and methods of its parent, animal. For the time being, as a placeholder, I'll add pass, just to demonstrate this. Class cat is also going to inherit from animal. And class mouse will also inherit from animal. Okay, I will collapse this for now. We'll create a dog object, dog equals dog, then pass in a name for this dog, because we have one parameter set up of name. This dog will be named Scooby, as in Scooby-Doo. Cat equals, call the cat constructor, This cat will be named Garfield. And mouse. Mouse equals mouse. Our mouse will have a name of Mickey. Even though there's nothing within this dog, cat, or mouse class, we should still have these attributes and these methods. If you inherit the animal class, you should have a name attribute, an isAlive attribute set to true. You can eat and you can sleep. Let's print our dog's name. Dog.name. Scooby. Print dog.isAlive. Our dog is alive. That is true. Let's have our dog object use the eat method. Scooby is eating. And sleep. Dog.sleep. Scooby is sleeping. Let's replace dog with cat. The name of the cat is Garfield. Garfield is alive. Garfield is eating. Garfield is sleeping. And mouse. Replace any instance of cat with mouse. Our mouse's name is Mickey. Mickey is alive. Mickey is eating. Mickey is sleeping. Even though these children classes are empty, we're still inheriting these attributes and methods from its parent, of animal. This is convenient because you don't need to copy and paste these attributes and methods for every single class. For example, if I were to copy these attributes and methods and paste them, well, we have a lot more code to write. And as a consequence, if I need to make a change to one of these methods, I would have to do that to every single instance of this method. For example, let's replace isSleeping with isAsleep. Well, now I need to find every single sleep method and change it manually. It's not too bad if you only have a few classes, but imagine if you have hundreds of classes. That's going to take a lot of work. It's a lot easier to write the code once and then reuse it, and I only need to make that change in one place, rather than make that change many times. So let's change isSleeping to isAsleep, and see if that works again. Mickey is asleep. Let's replace mouse with dog. Scooby is asleep. Not only that, but with children classes, they can have their own attributes and methods that are different from one another. So dogs have all these attributes and methods, and they can speak. Let's create a speak method, and I will print a unique message for dogs. Woof. Cats will also have a speak method, but it's going to be different. Cats will meow. Then for our mouse class, they will squeak.